Alright, welcome back, Calc Kids. We're going to look at 2.1b today. We're going to be looking at quadratics. And when we look at quadratics, the big thing we're going to look at is something called vertex form. Okay, so let's get going. This, you guys may remember this from good old chapter 1. So I'm going to go through it pretty quick. Describe how to transform this graph to make it look more like this. By the way, that's a 2. Okay. So I'm going to do a quick sketch here. We all remember that x squared looks like this, right? So now the new one, I'm going to draw in red. Oops, not crossing it off, just underline it. So, what's this negative 2 tell us we're going to do by the x? That tells me I'm going to move to the right 2 with my vertex. Remember, the vertex is this guy here. And what's this plus 3 tell us to do? Well, I'll go up 1, 2, 3. So our new vertex is going to be at the point 2, 3, right? By the way, not drawing a scale. Now what's this 2 tell us to do? Well, it's out in front of the x, right? And if it's out in front of the x, it tells us we are going to have a vertical stretch of 2, which means we're going to be more narrow. Right, so if I draw my graph, it's going to look like that. What you guys don't know is we just did a problem using vertex form. Our new vertex is going to be at the point 2, 3. And our graph is going to be stretched a little bit. It's going to be a little bit more narrow. Okay? So keep that in mind as we go forward. This is your first example. Let's take a look at the next page. Here we go. Okay. Why is this here? I don't know. I just threw it in for fun. Pretty much, if you have a positive coefficient on your x squared, it's going to open up. If you have negative, it opens down. Just think about this. If your a is positive, you're a positive person. That's a positive. That's a smiley face. That's a positive person right there. If it's negative, that's bad. You're a negative person. That's a good negative person's face. They're frowning. Okay? Positive A, happy. Negative A, sad. We'll even put a little tear here because they're crying. Okay. Your vertex form of a quadratic equation. We're going to be using this one quite a bit, actually. Any quadratic, ax squared plus bx plus c, can be written in the form this. This is going to be the noteworthy part. Okay, so that's your vertex form. And you guys probably saw this in algebra too. Let's go ahead and take a second, write that. And your vertex form gives you a lot of things. It gives you HK, which is going to be your vertex, right? And it gives you your A, which tells you if it's going to open upwards or downwards like we talked about before. And it also tells you if it's a stretch or a shrink, vertical stretch or shrink, okay? So that's vertical stretch or shrink. Okay? So that's why we like the vertex form, is because we can graph it right away without much thinking, without even having to use a calculator. Who'd have thought it? So again, this is the notework. Nice job, Mr. Twilliger. Come on, get with the program. This is your vertex form, and it's nice because you can graph it instantaneously. And guys, don't forget, because this will come up, this is also going to be noteworthy. Remember, h, your x and your vertex, equals your negative b over 2a, you know, for ax squared, plus bx plus c. And that will come into play. So keep that in the back of your noggin, okay? Here we go. Let's do some examples. Okay, so first example is use the vertex form to find the vertex and axis of the graph, this guy. Rewrite in vertex form. So first thing we're going to have to do is find our axis or our vertex. Okay? So we have to find our h. Okay, so we need to find hk so we can have the form a times your x minus h plus k equals y. Okay, so to find h, we would use our negative b over 2a formula, which in this example, negative b is going to be negative 8, because we're using these a, b, c, all over 2 times our a, which is 2, which is 8 over 4, which is 2. So we have our h, okay? Now to find k, this is the tricky part. For k, you take your h and you plug it into your equation. Because that's, your x is going to be 2 for your vertex, so you just plug it back in to find your y or your k. Times 2 plus 11. And my calculations are correct. I gotta put squared up here. I get 3, right? So I have my h and my k, and my a is already built in. This guy right here is my a. Okay, so I can write my vertex form. I do my a was 2 times x minus my h was also 2. I'm going to put in blue for this guy. Plus my k, which was 3. And that is what my y equals. And I'm forgetting one very important thing, that's squared up here. That's squared up here. Because it's a quadratic, you need to have it squared. Okay? So again, find your h, use your negative b over 2a. Take that, plug it back into your original equation for your k. And your a comes from your a if you're quadratic. Hey, is that easy? Okay. Here, I'll make that the trivia question. What TV show was I just referencing, and what was the character's name? I'm going to show you a tricky one. We're going to do the same thing we just did, but we're going to do it by completing the square. Now you're going to say, Mr. Welliger, why do we have to do it completing the square way and the other way? Well, it's important to know both, because completing the squares can be the way you deal with it when we start doing ellipses and hyperbolas. Okay, so it's just good to see it once. Okay. So we're gonna try to get this in vertex form again. Describe in vertex form. I'm always lagging. I'm gonna pause and see. Oh, I got it working. Okay. Let's take a look at this guy. I'm gonna rewrite this and put this 11 all the way over here. I'm going to put it over here so I leave some room to complete the square. Okay. First thing I'm going to do is factor that 3 out of both these. So I have 3 times x squared plus 12. And I'm going to put parentheses on this. And this 11 is just hanging out by itself. Okay. Oh boy, oh boy, oh boy. Plus 12 divided by 3 is 4, Mr. 12, x. Now remember, when we complete the square, you divide by 2, and you square it, and you add it to both sides, but there's only one side on this one, Mr. Twilliger. Good question. So what we do is we add it, and we subtract it at the same time. And you may be saying, are you insane? Well, maybe. Let's do this problem. So plus 4 minus 4 completed the square. Because we're going to take a look at this piece right here, and we're going to factor it. So let's do another step. Okay. I know I'm changing. One thing I'm also going to do is, what's 3 times negative 4, everybody? In unison? Negative 12. bring that 11 back down. Because when I do that, I don't even have to worry about that 3 out in front anymore. Or in front of that 4. Because I got rid of it. X squared plus 4x plus 4. Okay? Now that is something I can do this to, right? I can factor. Minus 1. And we're done. 3 stays in front, that's your A. Your H is -2. And your K is -1. Remember, because it's X minus H, so it's opposite of what you think it is, okay? It's opposite. Just like when you're moving, it's opposite of what you think you're supposed to move for your transformations, okay? Alright, that's it. If you want to look over that again, see what I did, go for it. I understand these are tricky. If you have questions on them, please make sure you ask in class. Alright, have yourself a lovely day.